We are sometimes interested in the conditional expectation of a random variable. The damage to a vehicle, given that it exceeds the deductible. The number of storms, given that it exceeds a certain threshold. The amount spent, given that a project is under budget. In that case, we can use the conditional probabilities. And the important thing to remember, conditional probabilities are probabilities. So, for example, suppose the damage is uniformly distributed over some interval. If we have a deductible of $200, what's the expected payout of the policy and the expected payout if the damage exceeds the deductible? Since this is a uniform distribution over the interval, our probability density function is if the damage is under 200, the payout will be 0, and if it's over 200, the payout will be x minus 200. So the expected value will be a whole bunch of zeros and some amount for damage exceeding the deductible. And that will be to find the conditional probability when the damage exceeds the deductible, first we'll note that the probability that the damage is a certain value, given that it exceeds the deductible, that it will be if x is less than 200, the probability of that intersection is the probability of the empty set, which will just be 0. Otherwise, it's the probability that we equal that value, which corresponds to our probability density function. So first of all, we'll find the probability that our damage amount exceeds the deductible, which will be if the damage exceeds the deductible, the payout will be the damage minus 200. And so our expected value will be the sum, that's the integral, of the products of the payoffs and the probabilities, where since this is a conditional probability, we're going to divide by the probability of the condition. And so our expected value will be, or let's suppose the number of defects in a wire has a Poisson distribution with mean 3 in 100 meters, and let's find the expected number given that there are at least 2 defects. So we want the expected value of the number of defects given that there are at least 2 defects. And so the expected value is the sum of the products of the payoffs and the probabilities. So that's k, the number of defects, times the probability that there are k defects. And so our conditional probabilities will be, and if k is greater than or equal to 2, the probability of the intersection is just going to be the probability of the value. And so that conditional probability is, if k is less than 2, that intersection is going to be the empty set, and so our probability is 0, so we can omit these terms from our sum. Now, since x has a Poisson distribution with a mean of 3, the probability it's equal to any specific value is, and so the condition that we have at least 2 defects, that's the probability that x is greater than or equal to 2, will be so to sum this, note that the denominator and the e to the negative 3, those are constant, so we could remove them from the summation. So now to sum this expression, notice that this factor of k is kind of what you'd get if you differentiate something. So remember that our power series expansion for e to the x is, and if we differentiate it, we get, and if we multiply by x, we get, and so now if we substitute in a 3, we get almost our series expansion. The only problem is that our actual series begins at k equals 2, but we can split off that first term, and that gives us our series summation, which gives us our conditional expectation. Or suppose we sell 2 life insurance policies with a death benefit and premiums, and we have some probabilities. So if X is the payout, let H be the event the husband survives and W be the event the wife survives. Then what we want is the expected value of the payout given that the husband has survived at least 10 years. Since we're only looking at the cases where the husband survives, then there's only 2 cases worth considering. First, they both survive, which has a payoff of 0, and second, only the husband survives, which has a payoff of 10,000. And so our expected value is going to be 0 times that conditional probability plus 10,000 times that other conditional probability. So we can use an algebraic formula to find these conditional probabilities, but let's do something different and represent our probabilities using a Venn diagram with 2 events. The first event is that the husband survives. The second event is that the wife survives. And we have 3 regions. The husband survives and the wife doesn't. The wife survives and the husband doesn't. And both the husband and wife survive. Now, we're given the probability that the wife survives but not the husband, the probability the husband survives but not the wife, and the probability both survive. So we observe then that the probability the husband survives is this entire region, which has probability 0.97. And so that conditional probability will be which allows us to complete the computation of the conditional expectation. Finally, since 2 times 500, 1,000 has been collected in premiums, the excess of premiums over claims is